Hello, I'm Professor Johnson, and in this video we will be looking into hypotheses and what actually makes a good hypothesis and also comparing hypotheses with theories. So first of all, what makes a scientific hypothesis good? Scientific hypotheses really have to have two features. First of all, they must be falsifiable and they should be based on observations. They should be based on observations because this allows you to formulate a hypothesis that is really going to be a best guess for how some natural phenomenon in the world is functioning. Your hypothesis needs to be falsifiable, meaning that it will generate predictions that can be tested using experiments, and that a possible outcome of these experiments is that your hypothesis is wrong. And this is important because it allows you to move science forward. If you're testing an idea that the outcome, regardless of what it is, you can really stretch your hypothesis that it's been consistent with it, really isn't generating new knowledge, and therefore the hypothesis that you started with isn't good. An example of this, saying that evil spirits are responsible for making the remote not work with the TV. No matter what you do, even if you change the batteries in the remote and then it works, or if you change the batteries in the remote and it doesn't work, you can say that the evil spirits left once the batteries were removed, or once or they stayed with the remote and it had nothing to do with the batteries. Because you are evoking evil spirits in this scenario, which are not something that occurs in the natural world, they're supernatural and thus something that science cannot address, your hypothesis is not falsifiable and therefore not a good scientific hypothesis. Notice that I did not say that a good scientific hypothesis needed to be stated as an if-then statement. Statistical hypotheses do. Statistical hypotheses are more akin to scientific predictions. They are stated as if-then statements and really will make a prediction about a potential outcome. However, statistical or scientific hypotheses are based on the research question. So they're an answer to the research question and therefore not the same thing as a prediction. Also, I didn't say that a scientific hypothesis has to be correct. A hypothesis where the outcome is consistent with your hypothesis is no better than a hypothesis where the outcome was not consistent with your hypothesis. As long as you used observations to make a best guess in formulating your hypothesis, it doesn't matter whether your hypothesis was correct or not. So what is the difference between a hypothesis and a theory? Well, when you hear the term theory used by the general populace, they're generally referring to a guess they have about something. At best, they're using the term to mean the same thing as a hypothesis. At worst, they're just referring to a wild guess that they might actually have. When scientists use the term theory, they're actually referring to ideas that are really unified principles from several different areas of research that have all come together to give sort of an overarching idea about how the universe, the natural world, works. For example, the theory of gravity brings together the idea of how the planets move in space and how things here on Earth act when you drop them, and many other ideas and observations as well, and brings them together to give us the unifying idea of gravitational theory. So this is different than what the general populace use the term to mean, in that it's really based on many observations, many different experiments, and it really has very solid evidence backing it as well. All right, I hope that was helpful. I will see you in class.